Hi friends, in this video we see problems related to RC transient circuit. The first problem is in the circuit shown in the figure, find the time when the voltage across the capacitor becomes 25 volt, right? So we have to find the time, T value we have to find when voltage across capacitor becomes 25 volt after switch is closed. Okay, how we are going to see? We know in RC transient the voltage across capacitor is given by it is Vc is equal to Vs 1 minus e power minus t by Rc. Vc they have given. What is Vc? Vc is 25 volt. Vs is 100 supply volt. 1 minus e power minus t. R is 20 ohm. C is 10 power minus 6. Fine. Okay. So this is what they have given, right? Okay, if you simplify 10 power minus 6. Okay, so if you simplify it will become 25 into this is 100 1 minus e power minus 5000 t, right? So that will become, if you simplify, what you get is t is equal to 5.75 microsecond. So after 5.75 microsecond, what will happen? The capacitor voltage becomes 25 volt. Very simple problem. Okay. Second problem, a series RC circuit consists of 10 ohm, okay, and 0.1 farad. It is 0.1 farad, right? Okay, not microfarad. Please change it. 0.1 farad capacitor as shown in the figure. Determine Vc, that is voltage across capacitor, VR, and current through the circuit. So let us assume current through the circuit is I. So first I find I, right? From I find VR. VR is nothing but I into R. Vc is nothing but I into, sorry, Vc is just now only Vs in minus e power t by Rc. Okay, we will find first current through the circuit. So current through the RC, we know that I is equal to V by R e power minus t by Rc. V is 20 volt, right? This V, R is 10 ohm, e power minus t, R is 10, C is 0.1 farad. So if we simplify, what you get is it is I or I of t, right? I of t, we can say I of t is equal to 2 into e power minus t. So I we got, what is V? Sorry, voltage across VR is nothing but I into R. I is 2 into e power minus t. R is equal to 10. So 20 e power minus t volts. Next they ask Vc. Vc is equal to, what do you call, Vc is equal to, we can say I V by R, right? So what is V? Otherwise we can say Vc, just now I told Vc is Vs 1 minus e power minus t by Rc, right? So Vs is 20 supply voltage, R steady state voltage 1 minus e power minus t by Rc. This is 10 into 0.1. We know it is 1. So this is what Vc, right? So this is VR, this is I of t. So this is what they have asked. Okay, this is VR. Simple problem. Fine. Next one. In the circuit shown in the figure, the switch is in position 1 till steady state is reached and moved to position 2. So before steady state is reached, the switch is in position 1. After steady state, the switch is moved to steady state point 2. Find the energy dissipated in the circuit. Okay, so initially it is in position 1. Once it is reaching steady state, we know once the steady state is reached, what will happen? Capacitor becomes open. C is open and all the voltage will be, see the capacitor becomes open, so what is the voltage drop across capacitor? Open circuit, all the voltage will be dropped across this. So VC is 100 volt, right? So we understand why in steady state capacitor is open circuit, so all the voltage will be dropped across this capacitor. So it is 100 volt will be fully available across the capacitor. So VC becomes 100 volt. Now what we have to find at time t0, after steady state is reached, it is moving to position 2. Position 2 is this one, right? I read wrong. At position 2, the circuit will be, this is position 2, it will be like this. This is what position 2, right? Here 300 ohm, here 200 ohm, here 100 volt will be there across the capacitor, 100 microfarad. Okay, fine. Now what I have to find the energy dissipated in this resistor. What is the energy dissipated in this resistor? E is nothing but I squared of t dt from 0 to infinity. Fine. This is what the energy equation in the circuit theory. Hope you have used the same thing in signals and system also, where we have used for general signal E square x squared t dt, integral varies from 0 to infinity. Okay. So here only positive range we will take. So what happens here, you see, first I need I through the circuit. I we can find. What is my I? I of t is nothing but V by R e power minus t by RC. That we know. Current through the RC circuit. V is 100 volt. Initial voltage is 100. R is total resistance 500. This is 300 plus 200. E power minus T by R. R is 500 into C 100 into 10 power minus 6. So if you simplify, what you get is it is 100 by 500. So what we get is 0.2, 1 by 5.2 e power minus 20t. This is what current through the capacitor in steady state. What I want E value. E is equal to I square t, 0 to t. I is nothing but 0.2 e power minus 20t. If you simplify, right, square 0.2 e square t. So I square t. So square, if you simplify, what you get is, okay, this will give E is equal to, after integration, we will get 0.5 joule. Fine. So energy dissipated by the resistor is 0.5 joule. R, so I squared R, right? So please change it. I squared R. I forgot the formula. So this is I squared into R. You put R dt, right? So if you simplify, how can you get? You can make it, this is 0.2 square, 0.4 into 500, 20, 0 to infinity. E power minus 2t means e power minus 40 dt. This will be equal to 0.5 joule. So the answer is 0.5 joule, energy dissipated by the resistors, right? Okay. Next question is, the switch has been in position A for a long time, that is here. At t is equal to 0, it moves to position B. At t is 0, it moves to this position. Find voltage V of t for t greater than 0. So this voltage we have to find. That is voltage across capacitor, right? So what is voltage across capacitor V of t? V of t is equal to V infinity plus V0 minus V infinity e power minus t by RC. Right, what is V infinity? V infinity steady state voltage, V0 initial voltage. So we have two conditions. For t less than 0, switch is in position A. At t is equal to 0 only, it is moving to B. At t 0 only, it is moving to 0. T less than 0, it is in position A. So switch is here. It is, so only this part available. Fine. So when t is less than 0, what is the voltage across the capacitor? We have to find. right? So that is what V0. So V0 minus, that is T less than 0. That is given by, you see what is the, I apply voltage divider rule. This is 24 volt, right? So total voltage, right? So at T less than 0, the capacitor is open circuit because you see it is DC. For DC, capacitor is open. Okay, redraw that. For T less than 0, the circuit will be like this. How the circuit will appear? The circuit will appear like this. Switch is in position A. This is position A. 3 ohm, 5 K, 3K, 5K. This is capacitor is open, right? So I want to find VC. So the voltage across this 5K is capacitor voltage. Clear or not? Because capacitor is open, switch is in position A. The circuit is like this, 24, right? Okay, now this is 24 volt. So voltage across 5 kilo ohm is like a capacitor voltage. So V minus 0, right? So V minus 0 is, I apply voltage divider rule, total voltage into same resistor divided by total resistor, 5 plus 3. So 15 volt, right? V0 minus. When T is equal to 0, right? Capacitor voltage will not change immediately. So V0 minus V0 plus is equal to V0, that is equal to 15 volt. So we found initial volt, right? Because why V0 minus is equal to V0? Because capacitor cannot change voltage immediately, right? Similarly, inductor cannot change current immediately. So V0 is 15 volt. Now for T greater than 0, what happens? The switch is closed at, as per the problem, the switch is, it moves to B at T0. That means the switch goes to here. So circuit will have this 0.5, this resistor and 30 volt, right? So now for T greater than 0, the circuit will be like this. This 0.5 millifarad, this 4K ohm, 0.5 millifarad, this 30 volt. Fine. Okay. Now I want V, this is V0 I got. As per the problem, I need one more thing. What is that? V infinity. V infinity is nothing but steady state voltage. Right? So you see, this is again DC. So the capacitor is open. Right now the steady state voltage is V infinity is 30. What is the reason? Because at T is equal to 0, only circuit switch moved to point B. Fine. Now the capacitor reached steady state, right? So this is a constant supply. So V infinity is 30 volt. Okay, right. Now what we are going to see, we have to substitute in the formula. We got V0, V infinity. We have to get RC, time constant. Right, what is RC? Where R is R Thevenin into C. Here what is the resistor we have? R is only one resistor, so that is the Thevenin resistor. So 4 into 10 power 3. C is 0.5 into 10 power minus 3. So that will be equal to 2 second, time constant tau. Now what is the formula? Voltage across the capacitor V? V I wrote already. VT is equal to V infinity plus V0 minus V infinity e power minus T by RC. V infinity we found 30, V0 15, V infinity 30, e power minus T by 2. So it will be 30 minus 15 e power minus 0.5 T. This is what voltage across the capacitor, right? Simple, right? So I hope you understand the problem. If you have any doubt, please ask me in comment section. I will clarify. Thank you.